Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of product rule. So as per the problem, if f at x is equal to 1 plus x times 1 plus 2x times 1 plus 3x and that continues to 1 plus nx, find the prime of f at 0. So the first step in this problem is to find the derivative of this given function. Now this function is made up of multiple functions that are being multiplied. So the first function is 1 plus x, the second function is 1 plus 2x, and the third one is 1 plus 3x, and it continues all the way to 1 plus nx. So there are basically n binomials that are being multiplied. So for finding the derivative of this function, we'll have to use the extended product rule. So as per the extended product rule, so the derivative of this function will be, so the derivative of the first function times the second, third, and all the functions up to the last binomial plus the first function times the derivative of the second function times the third function and all the way to the last binomial plus the first function times the second function times the derivative of the third function times all the way to the last binomial and so on till we get to the derivative of the last binomial. So we can write the step like this. So prime of f at x equals the derivative of the first binomial, which will be 0 plus 1 times 1 plus 2x times 1 plus 3x and all the way to the nth binomial 1 plus nx plus now the first function 1 plus x times the derivative of the second function, which is 1 plus 2x. So the derivative will be 0 plus 2 times the third and all the way to the last binomial 1 plus nx plus, so now we'll start with the first function 1 plus x times 1 plus 2x times the derivative of the third function or the third binomial 1 plus 3x. So the derivative will be 0 plus and then all the way to the last one 1 plus, so I'll write it below. We'll start it time all the way to 1 plus nx. So if we continue with this pattern all the way to the last binomial, so the last part of the extended product rule will be, so we'll start with the first function 1 plus x times 1 plus 2x times 1 plus 3x and times the, and now we'll go all the way to the end and that will be the derivative of the last function or the binomial in the given function f at x and that will be 0 plus n. So there's a very tricky thing about this function that we should be able to visualize in our mind about the pattern we'll get when we find the derivative of this given function using the extended product rule. Now we have to find the derivative of this function at x equals 0. So in the next step, we can sub in x as 0 in this expression. So we don't have to simplify it first because that will save us time and steps. So we get prime of f at 0. So in the first part, so 0 plus 1 is just 1. So it's just 1 times 1 plus 2 times 0 and then 1 plus 3 times 0 and this pattern will continue all the way to the nth binomial, so n times 0. Now we'll work on the second part. So the first function will become 1 plus 0. Now in the second parenthesis, so 0 plus 2 is just 2 times 1 plus 3 times 0. And we'll have to continue this all the way to the nth binomial, so it will be 1 plus n times 0. Now plus, so the first function will become 1 plus 0, then 1 plus 2 times 0, and then 1, sorry, the third one will become just 0 plus 3, which can be reduced to just 3, and then all the way to the nth one, which will be 1 plus n times 0. And then now we'll just continue this pattern all the way to the last setup that we'll get at the end, and that will be the part where the derivative of the last binomial is used. So the first function will be 1 plus 0 times 1 plus 2 times 0 times 1 plus 3 times 0, and then all the way to the last parentheses. So 0 plus n is just equal to n. Now we can simplify it further. So in the first part, so multiplication by 1 doesn't change anything. And then 1 plus 2 times 0, so 2 times 0 is 0, so it will be 1 plus 0. The same thing in the third function, 1 plus 0, and the same pattern will continue all the way to the last parentheses, 1 plus 0. So this whole expression will reduce to just 1, and then plus. Now the second part of this extended product rule, so the 1 plus 0 is 1, then times 2. So this whole expression will reduce to just 2. So it will be 1 times 2, and the third parentheses will also reduce to 1, and it will continue all the way to the last binomial. So the second part will reduce to just 2. And then now the third part of the expression, so 1 plus 0 is 1, 1 plus 2 times 0 is also 1, plus 2 times 0 is 0, and then times 3, and then the rest of it will all be 1. So similarly we'll end up with just 1. And if we continue with the simplification all the way to the last part of the extended product rule expression, so we'll get 1 plus 0 is 1 times 1 plus again 0, 2 times 0 is 0, and then 1 plus 3 times 0, which is also 0, and times all the way to n. So the last part will be just n. So the whole expression reduces to this series. So now we have to find the sum of this series, and this is a arithmetic series because each term in this series is going up by a constant difference which is equal to 1. So to find the sum of an arithmetic series, we need to know the first term. So the first term is 1. The common difference is also 1 because each term is going up by 1 unit, and we have to add n terms. So the formula for, so I can continue on the side here. The formula for sum of a series is, so prime of f at 0 equals n over 2 times 2 times a plus n minus 1 times t. So prime of f at 0 will become n over 2 times 2 times 1 plus n minus 1 times 1. And this can be reduced to prime of f at 0 equals n over 2 times 2 plus, now n minus 1 times 1 is just n minus 1, and this expression can be reduced to just n over 2 times n plus 1, because 2 minus 1 is equal to 1. So this should be the final answer for the derivative of this given function at x equals 0. So these are the steps you have to keep in mind to solve a problem like this one. So we first have to use the extended product rule to find the derivative of the given function, because this function is made up of multiple functions being multiplied. And then we simplify each part of the expression we get using the extended product rule, and from that we get this arithmetic series, and we find the sum of this arithmetic series, and that is the prime of f at 0. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.